Awesome. Let's do a quick sound check. Check. Hey, check. Wait. Yeah. Okay. And this just kind of shows you any idiot with enough software can be on YouTube, right? In this case, I'm the idiot with enough software. So let's get started. Okay, these first few are just very, well, just really applications of the rules. So what do we got here? We have 3x cubed, 3 minus 2 and 5. So that's 3x cubed minus 2x squared. Is that minus 5 or plus 5?
Plus 5.
Thank you. All right, and this is question 1 again. And the main thing to remember here is the application of basically the general power rule. And generally, the power rule for integrals is as follows. You have ax to the n plus 1 dx. Okay. That's going to be equal to, ax to the n, my bad. Oh, yeah, we can. Thanks. Thanks, Ed. Okay, so this is just take the coefficient, take the old power and increase it by 1, shove it in the denominator. Take the x and increase that power again, and add a constant of integration. This is a general rule for powers. All right, so we're going to apply this here 3 times. The first thing we're going to do is take this 3, take the old power and increase it to 1 by 1. So that's the 4th power. So over 4, x to that new power, minus 2. Take the power and increase it to 3, x to that new power, plus 5. That's x to the 0 power. Increase it by 1. That's x to the 1st power plus constant. And that's question 1. Yeah. Question 2. What do we got? We got 4 plus 5x to the 3 halves. All on top of the square root of x dx. And like the derivatives, the trick here is to separate out that numerator. Remember, just like the derivatives, you can separate a numerator, but you can't separate out a denominator. I think Miss Yu might also tell you to give a negative power and distribute the negative power. I don't know if that's what she does.
She does.
Didn't she tell us to not use negative?
Yeah, in the final form, she didn't say anything about like working it out.
Or you could do this one, like we were saying, 4 plus 5x to the 3 halves multiplied by x to the negative 1 half dx. Those are actually equivalent to each other. All 3 of these are equivalent. It comes out to the same thing. Both of those come out to the exact same thing. Remember, what are we trying to say here? At every step along the way, you kind of want to ask yourself, have I integrated yet? And I have not integrated, I've just simplified. So I still need to increase power. So that is 4 over negative 1/2 plus 1 is 1/2. X to the 1/2 plus 5 over 1 plus 1 is 2. That's x squared at 1 constant. And then you're going to want to write everything simplified. Remember, no compound fractions, no compound rational expressions. So that's 8 square root of x plus 5/2 x squared plus constant. That takes care of number 2. Any questions so far? Great. 3. Let's see, what is 3? 0 to 9 is 5. And the next one is 3 to 9. I don't remember how much that was. That was negative 1.
I'll be right back.
And the question is, so the question is, what is the value of 0 to 3 f of x dx? The idea here is to kind of turn this into some kind of a equation, some kind of an equality. So it looks to me that if you add these two quantities together, you should get this quantity. Or to be more exact, integral from 0 to 3 of f of x plus integral from 3 to 9 of f of x is equal to the integral from 0 to 9 of f of x dx. And I think you can think of that as the area addition rule. You're taking this area plus this area equals the big area. Okay. Substitute stuff that you know. 0 to 3 is, of course, unknown. 3 to 9 is negative 1. 0 to 9 is 5. And I think that gives you the answer. 0 to 3 of fx dx is equal to 6. Darn it. No. Boy, I really messed this up now, didn't I? I just wanted to move this over because I forgot. All I wanted to do was lasso. Can't I just lasso? Thank you. Okay, questions on 3. And we are flying right by these. Let's take a look at question 4. Okay, so we want the derivative of this equation. So we want to take the derivative. So f prime of x is equal to d dx of the integral. Was that 1 to x squared or 3 to x squared? 1 to x squared
T cubed
plus rad t dt. So this is the derivative of an integral. Let me leave that as kind of notes. Derivative of an integral. So there are special rules here. And special rules are you're going to substitute the limits. So that's x squared cubed plus square root of x squared. And you're going to multiply by the derivative of x squared, which is 2x, minus, you're going to substitute the lower limit, so 1 cubed plus the square root of 1 times the derivative of 1, which is 0. So that simplifies to x to the 6th power plus x, the whole thing to the 2x. Now, or multiply by 2x. Do they factor or do they distribute for the answer? Factor, okay. So factor is 2x squared x5 plus 1. Burger time. You know, like 1984, there was a video game called Burger Time. Have you ever seen it?
So when you're taking the derivative of the integral and you're multiplying you plug in the limits into the equation, the 2x and the 0, that's the derivative of x squared and 1, right?
Yeah.
Okay.
Let's put that note there. This is equal to, this is a derivative of 2x of x squared. This is a derivative of 1. So awesome. What problem? What number are you on? 5? Cinco. 5. Find the average value on 0 to 2. That's 3x squared minus 2. So to remember the average, that's equal to 1 over b minus a from a to b of f of x dx. In our case, the average is equal to, was it 2 to 1, the 0 to 2? 0 to 2. So 1 over 2 minus 0, integral from 0 to 2, and I forgot what this was. What was it?
X squared minus 2.
X squared minus 2?
3x squared minus 2.
3x squared minus 2. Perfect. Dx. All right, so let's do this with antiderivatives. I'm going to try to avoid using the calculator where it's not necessary. Antiderivative of 3x squared is 3 over 3x cubed minus 2x. We're going from 0 to 2. You're going to substitute. That's 1/2 of 2 cubed minus 2 times 2 minus 1/2 of 0 cubed minus 2 times 0. Eight minus 4 is 4. Half of 4 is 2. Half of 0 is 0. So the answer should be 2. Yeah.
I'm a little bit confused for like number 1. When we find the antiderivative, we have to add the plus c. So why don't we have to do it over here?
You could add the c, but if you put the c here, you would just add it here and then subtract it here.
Oh, okay. Okay.
Not necessary. Let's put a note there. The plus c is only necessary for an antiderivative. Okay. If it's a definite integral, not necessary. I'm guessing 102 starting? 102 starting? 101?
No buses leaving.
Buses. Ciao. Okay. And burger time. Do you feel like you're looking at a fish tank? I feel like I'm looking at a fish tank. Don't do it. Don't do it.
Like in the zoo where they say don't tap the glass if you really want to. The aquarium where it's like, I like the my word. This is the human zoo. Oh, they can't see it. They can't see us for one way. Start flipping them off. They don't want to look at me or they can't see me? They don't want to look at me. Alright. Because I got Emily right for that.
Are we making too much noise?
Oh no. We can't hear you at all.
I'm sorry.
Oh, alright. I thought we were talking.
No.
Why are they getting it?
They're cleaning up for a Tribune. Okay, I'm gonna need your help because I can't do both. Is this number 5 or 6? I heard both.
It's 6.
Okay.
Oh, the next one?
Okay, we have X's. Can you give me the X's?
0, 0.5, 1, 3.5, 4.
And then we have F of X.
9, 2, 8, 5.
And we are supposed to figure out a, I think it was a right-handed rectangle rule. Okay, so I'm gonna keep going with this chart. My first intervals from 0 to 0.5. These are intervals of X. 0 to 0.5. Next interval is from 0.5 to 1. Then from 1 to 3.5. And then 3.5 to 4. Okay. F of X, oh, sorry, delta X. That's 0.5. Another 0.5. 2.5. And another 0.5. Next, how about our F of X? Now, we wanted the right rectangle rule.
Yeah.
Okay, so the first one is F of 0.5. F of 0.5 is 2. F of 1 is 2. F of 3.5 is 8. F of 4 is 5. Area, 1. 12? No, 16 plus 4, 20. 2.5. So, yeah, the last thing, the integral from 0 to 4, yes, you should write the integral, is approximately equal to 1 plus 1 plus 20 plus 2.5. I hope you notice that I'm writing this addition every time. Okay, so that should be a strong signal that you should be writing the addition every time. I hope. You can never tell. Okay, so that's approximately equal to 24 and a half. Right. Yeah.
How did you find F of X again? Like I'm blanking out.
Well, if it's a right rectangle rule, we just take a look at the right side, which is 0.5,
Okay.
and we look at F of 0.5 in our table.
Oh, okay, so if it was the left-hand side, you would do like 9, 2, 2, 8.
Yeah.
What if it was midpoint?
We'd have to change our intervals.
Oh, okay.
Will you give us a midpoint? Someone said.
Possible. Okay, 7. 7. Let's see. We want a trapezoidal rule with n equals 4 to get me 0 to 7. Okay, now I think we're going to want to use subintervals of all the same length. So delta x is going to be equal to b minus a divided by n, which is 7 over 4, which is 1.75.
Was that b times a over n or b minus a?
B minus a. Okay. B minus a. And that just tells me what my delta x is. B minus a is the length of the entire interval. N is how many we want. You don't really need this formula, I don't think. You don't need that floating around your brain. You just need to really think about how it works. Okay? Okay, so I'm going to actually use the formula for trapezoidal approximation from a to b of f of x dx. That's going to be approximately equal to delta x over 2 f of a plus f of a plus delta x, nope, 2 times plus plot plus 2 times f of b minus delta x plus f of b. That formula looks a little different than the one we used before, but trust me, it's exactly the same. Okay, our delta x was 1.75. Yeah. Isn't that the formula? Trapezoidal formula? Yeah.
So in the question it says use a trapezoidal rule, but if you do a chart for the trapezoidal,
Same thing.
so it's okay if we just.
Absolutely.
And you can only use this when all the intervals are equal distance.
Yes.
Like just
Remember that this is the formula. Formula only if all delta x's are the same. All delta x are the same. That's correct English, right?
yeah.
Are the same.
What are the dot 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 scores in the middle?
Because we don't know how many we're going to need.
Oh.
Yeah.
What do you mean how many we can?
It depends on how many intervals we have.
Oh,
Okay.
okay.
So this is really dependent on how many intervals we have. Let's do this. F of a, that's f of... I forgot. What is a? 0? Plus 2 times f of 1.75 plus 2 times f of 3.5 plus 2 times f of, is it 5.25?
Is that 3.5?
Plus f of 7. That's not going to come out like an S7. Ah. There we go. Okay. And let's also remember that f of x was given to us where f of x is equal to x squared minus 7x. Okay. So this divided by 2 is 0.865.
.875.
0. What?
Wait, 1.75 divided by 2
Yeah.
is 8.8 or 0.874.
875. Okay. 7/8, yeah. F of 0 was 0. Plus 2 times f of 1.75 is negative 9. Negative 9.19. Is that exact? That seems like it's not exact.
I think I rounded
Okay.
it. That's not 3 times that.
It's negative 18.375.
Well, is it, no, oh, because I didn't multiply by 2 yet.
Oh, okay. Let's not multiply by 2 then.
Oh, okay.
2 times, what's f of 1.75?
Negative 9.1875.
9.1875. Yeah, don't round it yet. Yeah, only round at the very end. Plus 2 times, what's f of 3.5? 12.25. Plus 2 times, what's f of 5.25? Okay, so negative 9.1875. And then f of 7, 0. Wow, that's neat. Oh, it's a parabola. Parabola with roots at 0 and 7. So it means it has a vertex at 3.5, right? How? Okay, and when we compute that all that together, okay, so what is this approximately equal to? Where'd that go? There it was. There it is. It went here. No.
Negative 10.
Right. And what did we get? I'm sorry, what did we get here?
Negative 53.59.
Wait.
Exactly?
No. But that's all you put on the use on the answer.
Oh, okay. We're going to need that, though. 53,
53.5938.
5938. Burger time. You know,
Oh, yeah.
Wait, what's the rule? Is the rule like round to 3 decimals unrounded, or is that what's your?
yeah, that's the way I prefer it. 3 decimals unrounded. At the very end.
Yeah.
Only at the end.
Okay.
Okay, how are we doing? I feel like we've been doing this for a little while.
About
How long have we been doing this? About half an hour? Okay, let's do a couple problems and then we'll take a small break. Eight.
is 8 a calculator?
No, I wouldn't do it with a calculator. Okay, so we want the average of sine x okay, so gosh, I hate to keep telling you this formula over and over again, but I'm always not sure. Average is equal to 1 over b minus a, integral from a to b of f of x dx. Average is equal to 1 over b minus a. B minus a is pi over 2 minus pi over 4. Integral from pi fourths to pi halves of sine x dx. Okay. Pi over 2 minus pi over 4 is pi over 4. So that turns into 4 over pi. Antiderivative of sine x is negative cosine x from pi over 4 to pi halves. To kind of reiterate what we said before, you don't need the plus c because this is not an antiderivative. Okay, so let's simplify that again. That's 4 over pi times negative cosine of pi halves minus 4 over pi negative cosine of pi fourths. That is 4 over pi times 0 minus 4 over pi times negative root 2 over 2. And that simplifies to 2 root 2 over pi. Well, the derivative of cosine is negative sine. So we have to work backwards on that. Okay. How are you liking this multiple choice so far?
Is it multiple choice only? Is it?
No, it's not. Where are we on right now? What number?
9.
Yeah. You have to memorize that. I'm not going to give you an average formula. Actually, let me be clear on that. You're never going to get the average formula. Never. Geometric formula, occasionally. Average formula or a formula pertaining to calculus, no. Not even on your AP test. 10.
Not even on the response section here. Wow, okay.
9?
Yeah, we're on 9 though. This was 8.
Is evaluate the integral again.
Evaluating, do I remember that x4 minus x3?
Yeah, over x.
Dx. Should we do this the Miss U way? This is 9? Oops. How did you do it? Now remember, I really don't care how you do this. You can any way you like. At every step of the way, if you keep writing those integral signs, you'll be sure to do the integral eventually. I think one of the big slip-ups I see for this problem is someone will simplify, and then they've simplified, and they said, okay, I took the integral. And they didn't take the integral, they just simplified. A crafty test maker will always just simplify and substitute without integrating, and that would be one of the answer choices.
That's really
Yeah. If I was making this test, x squared minus x plus c would be one of the answer choices. For sure. Yeah.
isn't it?
Yes, yes it is. Yes it is. I should work for ETS. You think they'd hire me? I'd probably get more money.
Wait, I don't understand why it wouldn't be. I still don't understand why it wouldn't be x. Why wouldn't there be a plus?
We haven't integrated yet. We've only simplified. We haven't integrated.
We factor as an exponent.
Okay, that's an answer. Now we've integrated. So really keep track of whether or not, really keep track of whether or not you have integrated.
It's x squared. It's x for you.
Yeah, x squared.
Answer 1/2 x squared.
Oops, sorry.
You should do that one too.
That probably wouldn't be one of the answer choices though. That's more rare.
Yeah.
Okay, let's do 10, maybe 11. 10. Oh yeah. Secant cubed theta, tangent theta, 1 plus tangent squared theta,
That's an identity.
d theta.
For which identity?
Yeah, but it's an identity.
Yeah. So the appropriate identity here is 1 tan secretary.
Wait,
One.
isn't it 1 plus? Oh, you plus secant squared on the bottom.
No, typo.
Oh.
Did you get the email?
Check that.
Okay. So we're going to use that identity. You get secant cubed theta tangent theta over secant squared theta d theta. Again, you're going to utilizing the 1 tan secretary.
And secants cancel out, right?
Yep. Do some cancellation.
Oh, that's
Secant tangent is actually a derivative of a trig function. This is the derivative of secant theta.
plus C.
Antiderivative, so plus c. Which reminds me that one of the answers would probably be secant theta, tangent theta, huh?
Oh, tangent is
Yeah.
secant squared.
Is there a possibility that
double angle, yeah, possible. Okay, you're responsible for double angles, trig identities, and half angles.
Wait, what's happening?
Can you write down half angles? Half angles.
Can you write this down?
I guess I can. Les trig formulas.
Yeah.
Formulae. Is formulae the plural?
I have no clue.
Sure, why not?
Let's pretend.
Pretend that it is.
Okay, so, wow. Let's see if I can remember this. Sine 2 theta is 2 sine theta cosine theta. Okay. Cosine 2 theta is, I think it's sine squared minus cosine squared.
Yes. No, cosine squared. No, it's the other way around. It's cosine squared theta minus sine squared theta.
Minus sine squared theta, tangent 2 theta, and really tangent 2 theta, the tangent ones are the last ones you should memorize because not so necessary. I think this is tangent squared theta, or no, 2 tan theta.
2 tan theta minus 10 squared theta.
Thank you.
Whoa, yeah.
There's this great resource also, it's called Google.
We can sit on the test.
It's very helpful for this. Can you remember how half angles work? No, I don't remember the half angle formulas.
Okay, so you kept it from test.
What do you mean? What are you talking about? Sine of theta over 2. I don't want to be wrong. I totally don't want to be wrong here. Oh wait, I have a phone.
Dear Mr. Freud.
Oh, you have it up?
I think these are all of them.
Thank you. Thank you so much. There we go.
How did these even come up with these? How does this even happen?
How do you form like one question?
There's probably a bunch of people who nothing knows and they stare at stuff like this and they just
Like, who made them in charge of they can make rules like this and figure out how it works? Like, I don't know. It's so like conceptual, like they're pulling stuff out of their hat. Like, oh, this equals this.
You know what? You know what? We'll make it. We'll make it like that.
The math god says
We can just say that it's this.
I know that one. I learned it.
Get that. You're funny.
Doing the face.
All right. Sorry. Let's just continue. Your Pythagorean formulas.
so no half angles, or are we not doing half?
Yeah.
Are you gonna be kind to us and not give us half?
Oh, why don't you say no?
Why don't you just magically be on the test?
We'll leave it there for now. Okay, I think we'll do, what's the next one? Okay. I think we're going to take our break here then.